So far, what you have at your fingertips is a design challenge, constraints and criteria, benchmarked solutions which have been ranked, and now lots and lots of concept ideas because you just finished with concept generation. So what's next? Well, you might have guessed it, concept selection. Now it's time to pick the best idea, the best design idea you possibly have. And how are you going to judge that? You're going to judge it based on the criteria and constraints that you developed from the customers at the beginning of the project. So here's the process sort of graphically. You have ideas coming in, they're little yellow dots on the left side, and you generate lots of concepts. Those are the red dots. And then concept screening, which we're going to talk about in this talk, is going to reduce it down to a smaller number. And then concept scoring, which is blue in this case, is going to reduce it down even to a smaller number. And then when you do concept testing and prototyping, you'll actually pick the best of maybe 3 designs or 2 designs, or maybe even from 1 design. So we're taking 10 to the 10th ideas. I know some of you had 1 trillion ideas. You came up with 1 trillion concepts. That's fantastic. We're going to go down from 1 trillion or 10 trillion in this case to, or 10 billion in this case, sorry, to 100 to 10 down to 1. So how do you evaluate the options? You use 2 sequential processes. One is concept screening, one is concept scoring. So let's first of all do concept screening. In this case, the first thing you do is you look at all the solutions you generated for each of the functions in the concept combination table. Now think about that for a minute. You have a concept combination table. You have lots of different columns, each one for a particular function, and you have lots of ideas in each column. The first thing to do is to reduce the number of solutions you have in each column. You came up with some really wild solutions, some really innovative solutions, out-of-the-box solutions. Now it's time to go back and look at those critically. Critically means rank them based on the feasibility and estimated goodness using your criteria and constraints. Keep only 2 to 5 solutions in each function, in each column, and they can be ranked from the best to the worst. This can be a mix of safe and innovative solutions. Then you create a new concept combination table with only those solutions you just chose in each column. So each column will have 2 to 5 solutions. Here's an example of one. It has, actually this has 4 in the first column, 2 and 2 in the second and third columns, for a total of only 16 different combinations. This is sort of what you want to get down to, something that's manageable. Well, once you do that, then you take all those ideas, all those combinations you have in the concept combination table, and you put them in another table called a concept screening table. You'll define the best 8 to 12 concept combinations from your table, maybe even more. You can go up to 20 if you want to. You'll name each combination with a descriptive title, and then you'll create something called a concept screening table, which I'll talk about in a minute, and then you'll rank the concepts based on the criteria, and you'll have this reduced from maybe 8 to 12 to 20 down to maybe 5 or 6. So let's look at a reusable syringe design. These are syringes from Novo Nordisk. In this case, there are 7 syringe designs. There are only 4 shown on this page, but they came up with a total of 7. They combine different functions and different solutions in the concept combination table, and they named each one ABC. This should be ABCD, not ABAA, and each one has a different name. Master cylinder, rubber brake, and I don't forget what the 2 names of the other ones were, but they weren't master cylinder. Every one has a unique name. This concept screening table looks like this. You put and here you can see C, D, and E, F, and G, which are rubber brake, ratchet, plunge stop, swash ring, lever set, and dial screw along the top. These are the 1, 2, 3, 4, 5, 6, 7 ideas, 7 concepts. We're trying to reduce it down to something smaller. So we put the selection criteria over on the left. Your criteria, you know what those are because you have either asked the customer or you've been given those in class. And then you pick one of these ideas as a reference idea. And the reference idea should be one that you know and understand pretty well, and probably will be one that would be pretty in normal design, or maybe a standard design that you would see, or maybe close to a standard design. So in this case, the plunge stop, which looks like a standard syringe, has been chosen as the reference idea. In that reference idea, you put all zeros, and you're done with that one. All zeros means that it's not better than, not worse than, but equal to another design. You're going to then compare all these designs for each criterion to the reference. So the way you do this is, let's start with master brake on the left. Master brake, ease of handling. You look at the master cylinder. not master brake. You look at the master cylinder and you compare it to plunge stop as far as ease of handling. If it's easier handling, you put a plus sign there. If it's worse handling, you put a minus. And if it's about the same, you put a 0. They evaluated it and came up with a 0. You go down to the next one, ease of use, or you can go across to rubber brake if you want to. Let's go across to rubber brake. Rubber brake, we find out it's about the same as the reference. The ratchet is actually a little worse. The swash ring is the same. The lever set is worse, and the dial screw is worse. We go down to the next criterion, ease of use. We find out the master cylinder is about the same as the plunge stop. The rubber brake's slightly worse. The ratchet's worse. The swash ring is equal to. The lever set is better than, has a plus sign, and the dial screw is the same as the plunge stop. So you go through all of the design concepts and all of the criteria, and you evaluate them all with respect to the reference idea, which is the plunge stop in this case. When you're all done, you add up the numbers. So in the first column for master cylinder, you see we have 2 plus signs and no negatives, and everything else is a 0. So the sum, if we sum those up, assuming the pluses are plus 1, it would be 2. 2 pluses, 5 zeros, and no negatives for a total of 2. The next column has 1 plus, 4 zeros, and 2 minuses for a total of minus 1. There's 1, if you add up plus 1 and minus 2, you get a minus 1. So you go all the way across, you can see what the net scores are. If you look in the bottom row, net score, 2, minus 1, minus 2, 0, 1, 0, 0. And then you can rank them. The highest number is a 2, so that would get a ranking number of 1. The next number is a 1, and it gets a ranking of 2. It's the swash ring, E. It has a net score of 1 and a ranking of 2. There are then several, a couple of them that have zeros. 3 of them have zeros, which would be ranked 3. Actually, 3, 4, and 5. So the next one after that would be ranked 6. So we see B, design B is 6, and design C is 7. Okay, I hope that was clear. If it's not clear, you can go back and read the text for this particular concept screening table. So then we ask, are we going to continue development on these? Yes, we're going to continue development on A, no on B, no on C. We noticed something, though, when we were doing this exercise and when we were thinking about these designs, that we could combine some of these. We could combine D and F, for example, and get a new idea, DF, and we could revise G and make it actually better. And so we're going to have a revised G. We'll call it G+. So just remember that the goal of this concept selection is not to select the best concept, but it's to develop the best concept. So if you see ways to improve each of these designs with respect to the reference concept as you go through the selection, go ahead and do that. Change the design, make it better, and pop it to a higher ranked design.